Narayanan Srinivasan. I did my masters with him, not with him, he was my teacher. So he spent about 17 years in Allahabad University, and some of 2 years I was there. I learned a lot from him. His expertise lies in the area of attention, perception, and consciousness. He has several publications, books, and he is very eminent in the area of cognitive science, in the field of cognitive science. Currently, he is at IIT Kanpur, heading the Department of Cognitive Science. And yes, it's a great honor to have you here, sir. Welcome, it's over to you now, sir.
Can you hear me? Can you hear me at the back? Okay, so let me start first. Let me thank the organizers, Dr. Vedanta Institute, Dr. Aparna Pandey, and Dr. Sri and other colleagues from IIT BBS for inviting me for this conference. So I will be talking about attention and experience. Okay, no problem. So let me sort of lay out what exactly I'm going to talk about. I will talk about consciousness, but the word will be used in many ways during the conference. So let me simply say the way I'm going to use it. Basically, I'm going to talk about our day-to-day experience. Currently, all of you are seeing me and listening to me. So you have some kind of audio-visual experience. You're sitting in a chair, maybe some tactile experience, and so on. So one simple way that cognitive scientists, psychologists study experience is to say that, well, what are the properties of experience? And if we can do something about understanding those properties of experience. One obvious thing that we can say is that what exactly are we experiencing? Currently, perhaps, hopefully, you are seeing me, so you have a visual experience of me. And of course, this keeps on happening, right? So one, you have something called the content of your experience, and we can ask questions like, what exactly ensured or made this happen, that you have this particular content of experience at this particular time, okay? Experience, another way to think about it, and this was originally introduced by philosopher Daniel Dennett, is to think in terms of content, which is what you experience, and also vehicles, which is the term that you use, or you can simply think of it as mechanisms. And those vehicles themselves have properties. So one may want to understand the properties of those vehicles of consciousness, or mechanisms, or whatever word that you may want to replace it with. And when you look at those properties, both in terms of your content of experience as well as experience itself, it has lots of properties. For example, one of the things that I study, which I will not talk about too much here, are temporal properties. For example, your experience seems to flow. There is some continuity. There is some direction to it. Your experience goes from past to future, not the other way around, right? So experience itself has certain properties, some temporal properties. And one property that I'm going to talk about a lot today is gradedness. And I will introduce the problem a bit later, but is consciousness graded? This is one of the questions that scientists who study consciousness ask this question. In terms of methods, I'm basically trained as a psychologist. So I do psychophysics, goes back to 19th century, Gustav Fechner and so on. That is essentially started as trying to understand the relationship between some physical variable, which you can manipulate, and something that you experience, which hopefully that we can measure, and then exactly how they are related to each other. Right? So there is a lot of methodological approaches that have been developed in this domain called psychophysics, and that is essentially what you mostly will hear. Occasionally I try to use insights from phenomenology, although I'm not sure today we will hear that much. Okay, so what exactly are the questions that I'm going to discuss today? There are three here. First question is, does attention, and attention is something that I study, so one can ask, okay, I'm experiencing something, does attention actually influence your experience? That's the first question. Well, I can already tell you the answer. The answer is yes. I'm going to say, but we will see how. The second question is consciousness graded? And if so, does attention influence the gradedness itself? I'm going to say yes again. And does meditative practices, which again involves attention in different forms, again the question is, does it influence your appearance or experience of your visual world or whatever? Okay, so the question goes back, at least in Western sort of science in 19th century. There are three people. If you are a psychology student, you may have heard these names, otherwise you see them. So for example, Wilhelm Wundt said that one notices that when a stimulus reaches consciousness during a moment of particular inattention and then repeats at the same intensity, such as the unexpected chiming of a clock tower, the second reception of the stimulus is perceived not only to be clearer, but also more intense. So basically what they're saying that if you pay attention to your stimulus, it becomes more intense. Okay? In a sense, you experience it differently compared to when you are not paying attention. In contrast, Gustav Fechner said that a gray paper appears to us no lighter, the pendulum beat of a clock no louder, no matter how much we increase the strain of our attention upon it. No one by doing this can make the gray paper look white. So here is a contrast. He's saying, oh no, it actually doesn't matter. That your experience really doesn't change because you are paying attention. And William James sort of said both, essentially saying that attention makes a sense impression more intense, but there is a compensatory mechanism that nullifies the effect of attention. So in the lab, it was sort of difficult to show this for various reasons. It is much easier to show that attention improves performance. So you can measure accuracy, or you can measure reaction time, and then you can show that if you are paying attention, you are faster or better. But the question is, experientially, is anything changing? It's not quite clear. So we will jump more than 100 years. And look at this study. This is sort of a fairly classic psychophysics study. And this was done by Marisa Carrasco and her colleagues at New York University. What you will see is a fixation point at the center. Then there is a cue. The cue is simply a dot that flashes either on the left or on the right or at the middle. It's basically to sort of attract your attention to that particular location on the screen. There is a gap, 53 milliseconds blank display. Then the stimulus, I'm not sure whether you can see from the back, it's a small Gabor patch, which is essentially a sinusoidal grading multiplied with a Gaussian function. This Gabor patch is oriented this way, for those who can see it. There are two Gabor patches, and then you're supposed to make a response. What Marisa Carrasco did is that to ask people to say that, well, one of the two will appear as though it has higher contrast. Report the orientation of that Gabor patch which appeared brighter to you or had more contrast. Does it make sense? So she's not directly asking about contrast, but she is asking essentially to say that now exactly report the orientation. Once you do, oops, sorry, oh, there is a slide missing. Okay, so what she found is that the Gabor patch that appeared at where the dot flashed, that where the Q appeared, where you supposedly were paying attention, that appeared as having higher contrast than the Gabor patch that appeared at the unattended location. So the argument is that not only your performance is better, it actually appears to have a higher contrast. We took this and then we asked a slightly different question and then said, well, this is all contrast, it's a very early visual feature, fairly simple. What about some things that are slightly more complex? So the example that we picked is an emotion that is shown by a face. So we use emotional faces. It's very similar. So we have two locations. I don't know whether you can see this rectangle here. There are two dots, either they will flash on the left or on the right, or one dot in the middle. After some small gap of time, two faces will appear. Both of them could be somewhat happy. Okay, fine. Actually, the faces come from this line. So basically, for those who are seeing it first time, if you go from this side to that side, it will look hopefully a bit more happier. Okay, so this is of increasing emotional intensity if you go from here to here. So what you will see here is something that you will see throughout the talk. You will see a psychometric function, which is like a sigmoidal function. On the x-axis, you have the variable that you manipulate. In this case, emotional intensity of some 9 levels. And they are equally spaced. It is set up as an interval scale using some method, scaling method. On the y-axis is what exactly is something to do with appearance. It actually takes a difference. But basically what you see is this psychometric function for 3 different conditions. And the curve that you see on this side basically is when the face, for the face that appeared at the cued location, and the one on the right on this side is when the face is, for example, the dots come here, but the face comes here, or vice versa. Okay? And there is a neutral condition. So what happens is that the neutral condition is when there is no attention involved, but when the dots appear, the psychometric function shifts to the left, which essentially means if you come this way and you can interpret it this way, so something is 5, but basically whatever with a no cue, you see it as of emotional intensity 5, now it actually increases. So basically something which is 4 appears to you as 5. So basically in English, whatever that, if there is a happy face, the happy face that appears at the attended location is, you experience it as more happier, and similarly for a sad face, more sad. Okay? So the idea here is that attention, in this case exogenous cueing, where there is a cue comes and then sort of makes you look at a particular location in visual space, changes your experience. Okay, so that's one way of looking at attention, but attention has other ways of looking at it. So if you think of attention easily as a spotlight, you can also change the size of the spotlight. So you can make this spotlight size smaller or larger. One way to do it is to make people do certain tasks, which will essentially have a smaller stimulus or a larger stimulus. So small or large. You also have these what we call hierarchical stimuli, which is essentially a large letter made up of small letters. So in this case, the 8 is made up of small s's. Sorry for those at the back row if this is difficult to see. This is a large S made up of 8s. So we call this global S and local S. So small, large, global, and local. And then what we do is that here is a blue square. There is time, you can actually do this. You can keep staring at it. Actually, you can do it even now. You keep staring at the center for a while, say 20, 30 seconds. Then if you blink your eye, you will see a yellow square as an after image. Okay? So as you keep looking at this, these letters sort of at the middle flash once every second, and then you have to count the number of times a particular letter appears. So the idea is that you are made to perform a task in the middle. The task involves differences in scope of attention, basically changes the spotlight. Then we are looking at the effect of that on the after image, and one property of the after image you can measure is the duration of the after image, how long the after image stays. Remember, the after image, there is no stimulus on the screen, it's just something that you experience. So we want to see exactly one property first, the duration of the after image. Is it affected by attention that you pay to this central stimulus letters that flash on the screen? The answer is yes. So what you see on the results here, on the y-axis you have after image duration, and as you can see, for example, the first one is, well, let's just go to the that side. When the letters are very small, when the spotlight is small, then actually the after image durations increase quite a bit, it's very long. Whereas when the letter is very large, the after image duration is small. So there is an inverse effect here. Similarly, whether your attention is sort of to the global or local level of the stimulus, again the duration changes. So for example, your duration is much longer for the local compared to the global here. Okay. So the idea here is that as the scope increases, the duration of the after image decreases. Okay. So the idea is, rather than directly showing is, we are using the after images as a sort of technique or a method, because then you can measure its duration, because it will come and go. Right. You can also take the scope of attention using these global local stimuli and then say that, well, the spotlight, think of this attentional spotlight as some resolution. I can change the size. Remember, in our experience happens in time as well, right? So the question here is, what happens in time? If I change my spatial resolution, I can have my spotlight small or large. What is going to happen in the time domain, right? In the time, what happens? The idea is that there should be, as you know, there are enough people with physics background here, there may be something that's happening in the time domain as well. So the way we measure temporal resolution of your experience is essentially using these two dots. We present two dots very briefly, and then we ask you which dot came first. Okay? This is called temporal order judgment, and we can use it to measure the temporal resolution of your experience. So typically speaking, this is of the order of around 20, 30, 40 milliseconds with some variability. Okay. And you can measure the psychometric function here. Now what we do is that when you construct get a psychometric function, the slope, basically if you see in the middle part of here, if it's more steeper, then your resolution becomes better. Okay, so steeper here is better resolution. So now what we do is we force you to pay attention either to the large global level or the local level. That we do by instruction. And then make you do this temporal order judgment task, and then see, well, if there is an effect on temporal resolution because your spatial attention is changed, then it should show up here, and that is what you see here, right? So if, for example, you are doing the global task, then it's much steeper, the blue, compared to the local task. The global is larger spotlight, but better temporal resolution. When the spotlight is large, you have poorer spatial resolution, but you have better temporal resolution, and vice versa, sort of complementary effects. Okay. The second question that I'm going to talk about is gradedness. One of the questions that have puzzled the consciousness researchers is that, is your experience graded in some sense? What exactly does it mean? One simple way to think about it is this, right? There are lots of processing that happens in your mind, brain, whatever, unconsciously. Suddenly some threshold is crossed, let us say for that particular content, boom, you are aware of it, you experience it, okay? In this case, it's sort of discrete. Either you are not aware of something or you are aware of something. So you can think of it like a step function, okay? That's one kind of theory out there, and there are theories that support this. The other version is to say, no, that's not true. You can have some sort of intermediate graded levels. You are sort of vaguely, well, a lot of times we have this feeling, right? I sort of vaguely maybe experience something, but I'm not really sure. So perhaps there are states like that, and that's also the way your experience works. And that is the gradedness theory. So the idea here is that it could be graded or it's not graded. Some have argued that it's yes. We are going to say it's yes, and I will show you how we actually do it. And the other question that I have been continue to be interested in is how does attention influence this gradedness itself? Okay. So let's look at an actual experiment in the lab to do. So what you have is this, again, large letter made up of small letters. There is a mask. In between this letter comes for various amounts of time. So what is manipulated here is display duration starting from 16 milliseconds to 112 milliseconds. And what you see here is again your standard psychometric function that goes from low to high like this. The gradedness is essentially measured by the slope, okay? Now, ideally speaking, if for example there is a threshold, if for example you manipulate this target duration, you should basically say, no, I don't see it, and then you go jump and then say, now I see it, if there is actually a fixed threshold, okay? What you get is, of course, the psychometric function, but typically what people use is accuracy, right? Now, one of the problems with accuracy is that you can guess also, right? You can guess it right. So it's not really quite clear you actually saw it or you guessed it and so on. And there are ways to handle it, but one of the ways that we want to move away from it is to sort of go from this. In accuracy, you are either asked, it's a two alternative force choice, either did you see something or you did not see something, right? You have two key places. So the next level is to sort of relax it a little bit, and then people have started using a 4-point scale, okay? I don't see it at all clearly. I sort of vaguely maybe see it a little bit, sort of see it reasonably well, but really see it, okay? Think like that, okay? So you have 4-point scale, and then what you can do with this 4-point scale is like just with like accuracy, you can also take the mean for every condition, and then what so happens, again you will get a psychometric function like this. So now this is a psychometric function for, this is called perceptual awareness scale ratings. So this is for the ratings. You get a scale, you get this. Now what we manipulated is, we asked people to detect a letter at the global level or the local level, and as you see here, the slope of the curve also changes. It's also shifted, but which essentially means global is always easier, so that's why the global will be on this side, that is the red curve. But there is also a difference in slope which we get. So the idea here is that if you change attention or the level to which that you pay attention to, the slope changes, which means gradedness changes as a function of that. So sorry, those are the results are here. You can see here that there is a difference. This is an objective performance, that's okay, but you get a difference in slope as well. You can also do some correlations with essentially how many times, because it's a 4-point scale, the middle ones are the ones where things are sort of fuzzy, okay? So you can take those middle values, basically in a 4-point scale, 2 and 3, okay? And see the proportion of those ratings and do your correlation with the slope, and you will see that the correlations are significant, okay? Now, this is one way that you can manipulate attention, but there are other ways to manipulate attention as well. And one way you can do it is essentially make the task a bit more easy or difficult, what we will call load, some kind of attentional load. And attentional load can be you can be made more difficult or easy by you focus on these 6 letters here. So what, for example, in this particular case, you have essentially a bunch of O's or zeros, if you really want to think about it, but there is one letter, right? This is fairly easy to detect. So in both cases, you have to detect the letter S, but in this case, it's easy to detect. In this case, it's slightly harder to detect. So think of this as low load and this is high load, okay? So your job is to detect the letter S, which you have to do, not a problem. We can measure its accuracy, we can also measure your reaction time for it and so on. The other thing is that you will see the subject saw a scene at the background. And what we do is we manipulate the contrast of the scene, okay? So we are really interested in the scene, not in the letters. The letter is just a way to manipulate your attention. We are interested in the scene, and in this particular case, the scenes are, the subjects simply have to say, is it an indoor scene or an outdoor scene? Okay, like a natural scene, fine? The reason why this is interesting is that identifying the gist of a scene is very fast. Subjects can do it with very brief presentations. And a lot of arguments and studies have argued that you don't even need attention for it. It's like your pre-attentive processes can actually do scene recognition, okay? So it's very easy. You don't need attention, but we want to show you actually attention influences it and also influences gradedness. So the main thing of interest is the scene recognition. And again, we use, is it indoor or outdoor? And then there is a 4-point scale as well. Okay, fine. So again, you get psychometric functions. This is for objective performance. This is straightforward, right? If the primary letter task is easy, your scene recognition is generally better. It shows up as the psychometric function on the left, the green one. The red one is, sorry, yeah, the red one is for the high load. And this is accuracy, no problem. And you get some effects, but you skip it and move on. With the perceptual awareness scale ratings, again you see there is a difference, but you can see that the slope changes, the green goes a bit up also, and the slope is also becomes steeper. Okay? So you can measure the slope, you can measure also threshold as well. So basically all these are fitted with the 4-parameter exponential function for those who are interested. I can tell more. Okay, so what you get is there is some differences in objective performance, but more importantly you get a difference in slope, but not in threshold. Essentially shows that by manipulating your attentional resources for the letter recognition task, it changes the gradedness of your experience of the scene itself, which is what we are measuring. Now, exactly what we are saying it's attention, but exactly what kind of mechanism is involved. In psychophysics, typically people construct these models, and I have an example of a particular model here. This is called a perceptual template model. You can skip a lot of details. There are some noise sources. There are these boxes that do things, some transformations. But let's focus on the more important, relevant parts here. So think of this as a representation of the stimulus. It's a template. It's a representation of whatever the stimulus is. Now, attention, at least in these two cases shown here, can operate in two ways. So think of attention operating like an amplifier, signal enhancement, okay? So basically, if you amplify, what's going to happen? The height will increase, okay? So the representation will become much, taller and sharper also, but let's say taller. Now, that's one way attention can operate here. The other possibility, which is shown here, is that you can do filtering, okay? So it can operate like a filter, and actually does both. But in particular cases, the question is, how do we find out that attention operates like an amplifier or a filter in a particular situation, okay? What Liu and Dosher argued using their model is, you come on this side, and what you see here is a function. but you have three conditions. One is attended, unattended, and neutral. That's fine. The argument goes like this. So let's use something like a radio, okay? So old-fashioned people, if you have a radio station, you have adjusted, it's noisy a bit. What happens, it's sort of, very noisy, but then you increase the volume. Remember, your volume knob is essentially an amplifier, right? So if you increase the volume knob when the station is already noisy, what's going to happen? Anyone volunteer? Is it going to help? If it's a lot of noise already, you increase the volume, is it going to help? You listen better? No, because the noise is also going to get amplified. Okay? So when the external noise is very high, amplifier, right, will work in a particular way. When the external noise is low, the amplifier works very well. Okay, because now the signal more than the noise gets amplified. Okay, so if you add external noise and you get the effect of attention in this case with low noise but not at high noise, then that means attention works like an amplifier. If you add external noise and you get the effect of attention and noise is high, noise is low but not noise is high, then that means attention works like a filter. Okay? So you can actually add external noise to your stimulus, see where you get the effect, whether you get the effect here or here, okay, can tell you whether this is the mechanism that's operating or this is the mechanism that's operating. So that's the other way that the argument works. Okay? So you add external noise as a manipulation to your stimulus, then you see whether you get an effect in the lower threshold here, lower asymptote or lower asymptote is better, lower asymptote here, then that means it's signal enhancement. If you get at high noise on this side here, then that means it's filter. Okay? So we use the same logic. We added external noise, basically Gaussian noise to an image. We can manipulate the amount of Gaussian noise we add to the image, okay? And that's on the x-axis. Then people do this exactly the same thing. So what we manipulate is the noise levels, right? Which basically is the variance of the Gaussian noise that we manipulate. So what you see here is that this is subjective performance. Again, you get effects all three, but let's come to the subjective rating here. Now look at this part here, okay? So the effect of noise and the attention in this case is lowered here. It shows up here when the noise levels are high. You see the values are higher here, right? The noise levels are high, but not when the noise levels are low. So that essentially means in this particular case the load manipulation acts like a filter. Okay? That's one. The second thing is that we get a difference in slope. If this difference in slope is because attention is acting like a filter, then there should be a relationship between this effect and this effect here. Okay? So what we do is we take for each subject, we take the difference here. We take the difference in slope here. Remember, these are from two different curves and two different parameters. And then compute the correlation between the two. If they are related to each other in some form, then there should be a significant correlation, which is what we see here. We take this difference and correlate, and what you see is a significant correlation. So essentially indicating that whatever is the reason this curve is getting pushed up or down is the same reason potentially it's getting pushed left, changes the slope here. So the conclusion here is that number one, attention changes the gradedness of your scene perception. We manipulated load here. Number two, the sort of underlying mechanism of load is essentially like it acts like a filter. The last part of the talk, how much can I have? Decide I should speed up or? Okay, fine. So the other thing that I have been long interested in is looking at these perceptual experience effects with meditators. One, they are training their attention a lot in different forms depending on the method. And if that is the case, it should change their experience. Okay, so let's go back to this. All of you remember the blue square thing? Okay, so the idea there is that if you change the scope, your after image duration changes. What happens if you make the meditators do the same study? These were Sarat Samadhi meditators. And we made them do the same task. We also asked them the after images, because the first time when we did it, we did not really ask. But the second time we asked them also to rate the clarity of the after image. That is sort of how sharp it is. For those who have experienced after images in the lab or in the screen, it's sort of a bit fuzzy or blurry. It doesn't have very sharp boundaries, okay? So the idea here is that perhaps even that could be different for meditators. And here is what you see. Forget all the other conditions. Just look at the white bars and the black bars and leave the rest. Essentially, you can see the meditators have much longer after image durations. In fact, quite longer. I mean, not even close to non-meditators, okay? So number one, their after image durations are very long, okay? And if you look at their clarity is also higher, okay? They rated it on 7-point scale, sorry, 8-point scale. So the idea here is that, so meditators, number one, they experience the after image durations longer, and number two, the after images themselves have much higher clarity, okay? So you can sort of try to inform that maybe in the real world visual experience also is have more clarity, okay? You can't directly, it's difficult to measure, so it's sort of indirect. The second thing is that we were interested in control. So if you have experiencing something, you should be able to control your experience. Now typically, it's very difficult to see it, right? Your day-to-day experience, it's all looks the same. Not much different, okay? So one way you can study this is essentially using these bistable figures where your experience changes. So all of you, I'm sure you know this. This is a nickel cube. You keep staring at it, you will see the cube in one orientation. Remember, nothing is changing on the screen. Then your experience will change to another orientation, and it will keep changing back and forth. And you can actually construct a time series of the times it takes to switch from one experience to another experience, okay? And you can measure these times, these switching times. So this naked cube experience changes, and you can measure these times, and we call them dwell times. And these dwell times, obviously you can do it for non-meditators, normal folks like us, which you see in the blue bar here, which is typically around 3-4 seconds. So every 3-4 seconds roughly it switches, okay? It's not very periodic, it's not like a perfectly periodic switch. It's sort of non-linear switching, but it switches approximately, let's say 3 to 4 seconds, every 3 to 4 seconds. You look at here, meditators, they have longer switching times. Now this is actually known before even our study, so, but it's consistent that just like longer after image durations, they also have longer dwell times, okay, number one. Number two, with the Necker cube, you can ask people to control it. So for example, I can ask you to say, put your effort so that you are seeing the cube in a particular orientation, just hold it, don't let it change, okay? Seems like very abstract and difficult to do. Interestingly, people can do it, anyone can do this, a little bit, okay? So what happens is that your times increase, so the blue bar here is for non-meditators. You can see it is increasing, okay, even for non-meditators. But look at meditators, they are able to hold a particular orientation of the cube for a much, much longer period of time. So they are able to control, in this case, what they are visually experiencing through instruction, okay? Just what called endogenous, but basically through instruction. we also asked him to speed it up. Now here, you don't get actually that much effect. So there seemed to be some kind of a limit to how far meditators were not able to sort of bring this to 0 or anything like that. In fact, there is really no difference here. So there seems to be some kind of a hard limit here, whereas meditators were able to hold it for much, much longer. You can actually take the time series and construct, they actually form a particular distribution. You can fit it with this function. For those non-math, you can ignore it, but there is a function and there are two parameters here, k and theta. The only thing that you need to know is that these two parameters have some relationship, okay? Generally speaking, these two parameters are correlated with each other. So if, for example, if I pull the distribution this way, your skewness changes, but your variance also will increase, generally, okay? So typically speaking, the k and theta are fairly highly correlated with each other. Okay. Now, what happens in this particular case is that with meditators, actually let's first talk about non-meditators. Non-meditators, the correlation is high across all three conditions. It sort of reduces a little bit here because they are still able to exert some control. The idea is that the more control you can exert, the correlation will start breaking down or reduce. Okay? So for the blue, the non-meditators, the correlation is high. High means around 0.8, 0.9, reduces to 0.7 something here, and then this is still pretty high. But what happens is that for meditators, it's lesser here, correlation, not the dwell times, but it reduces to from 0.7 something to 0.4, indicating that they are able to exert much more control over their experience in this case. Okay? Another way you can look at control is that rather than by instructions, you can essentially use what is called a flanker effect. So the typical flanker effect is like Stroop effect, and also in psychology, that your flankers are congruent, your experience then will be for a particular orientation will stay longer. If it is incongruent, it will switch faster. Okay, so in this case, it's like a typical flanker effect, but basically, depending on the orientation of the flankers, if they match, the dwell times will be longer. If they don't match, it will be shorter. So this is what you see here, right? So the green bars are for congruent. This is with non-meditators. So you have longer dwell times when it's congruent compared to when it's incongruent. No problem, all expected effect. See what happens with meditators. Because now the meditators are able to essentially ignore the effect of flankers. So you get basically no flanker effect, which essentially means they are able to sort of, because their attentional processes are better, they are able to completely ignore. It's no incongruency effect at all for meditators. So both endogenously, that is, this is done by instruction. Exogenously, when there is a sort of distraction from the periphery, they are able to ignore in this context. The important thing is this is in their experience, because the stimulus itself is not changing, only their experience is changing. And the last one, and I will sort of skip this and I will jump. We also have looked at time, experience of time in meditators. Two things we show. Number one, with meditators, when we have, we again construct psychometric functions, and we essentially measure the 50% point called the bisection point. And what you see here is a difference in bisection point. So the meditators have smaller bisection point than non-meditators, especially when the task was more difficult. And similarly here, which we have seen before, we can ask people to do the global or the local task. Now rather than the temporal resolution, we are asking people to estimate durations and then measure the bisection point. And what you see here again is that, well, with non-meditators, there is a big difference between the global and the local levels in terms of the mean slope, similar to what we got there. But you can see the effect is gone for meditators. Okay? So this effect, which is typically present for non-meditators, is not present for meditators, and the slope is fairly high, I mean as high as this one for both here. So the idea is that you can show that, number one, that temporal experience also changes, number two, attention influences in a particular way, and because their attentional processes are trained better, you get different effects. Okay, so thank you. Let me acknowledge all the students. I mean, you may have seen some photographs. In between, Maruti, who did the emotion work, Shruti, who did the active images, Suraj, who is currently doing the gist of scene perception and gradedness, Amrendra, who has done work on meditators, and Ishan, who did the naked sleep study.
Any questions?
Sir, when you do this global and the local attention, do you do residual kind of or carry forward attention?
No, well, normally what we do is that we block it. So in one block, they do the global task. In another block, they do the local task.
Okay.
And we also counterbalance the order as well. So if you did it global first and local, then some other subject will do local first and global. So we handle those.
But if you do, let's say, very closely, let's say within very short span of time.
There are carryover effects. Here we do not want them, but we have done those in other scenarios more, which I have not discussed here. But yeah, you can get, so for example, you get typical carryover effects, right? So if I ask you to pay attention to the global level in one trial, and immediately in the next trial, the global level, let us say, then you are obviously faster. If I ask you to switch between levels, then there is a switching cost associated with it because you have to shift from a global level to a local level. There is also asymmetry in switching cost. So in some tasks, in one study that we did, switching from global to local was easier, but local to global was much more difficult, and so on.
Another question is, in most of the functions were, sigmoid sort of things. So because the sigmoid function is very much used in the deep learning or to introduce the non-linearity.
This is older.
Yeah, but we use lot in the sigmoid function
Yes.
to make the things non-linear kind of. So any correlate, I mean,
The
direct
neural
kind of
network
correlation.
people copied this from here.
I don't know. So
The psychometric functions,
yeah, maybe possible.
the shape of the psychometric function goes back to the late 19th
Right.
century.
Possible, yes.
So obviously, I mean, people have been aware that when you measure perception, the general shape that you get is a sigmoidal function was known much before the more neural network models. Okay.
Great also.
In fact, the initial neural network model used a hard limiting threshold function.
Right, yes.
I enormously enjoyed what you presented, and its importance is going to grow and grow because the machine learning systems are trying to maximize the attention that they can grab from all the users and increase the amount of attention they get from them. And so I wondered, some of your studies were on relatively short, sub-second timescales. I think one of them went up to 112 milliseconds, if I remember.
Yes.
What happens, have there been studies, if you go to much longer timescales, and if you do that, is there an age-related effect? And if there is an age-related effect, is it intrinsic to the age, or is it also influenced by the culture in which people are operating?
Okay, so complicated question. So the general answer is sort of yes, but the specifics will change depending on the kind of studies or what exactly we are looking at. So let me use time because it's easy. So people have changed the duration of the stimulus. So I can ask you to estimate the duration of a stimulus when it is sub-second, for example, or when it is longer. In fact, the last two actually came from studies where the presentation of the stimuli were for longer durations of few seconds. And of course, you can do 20 seconds or minutes or hours as well. In the lab, obviously, typically our experiments run for 1 hour and we need to do many trials. So we can't do experiments that run for hours in the lab. But there are other kinds of field studies that people have looked at it. So yeah, so different time scales, number one, sometimes show different effects. So in terms of time, the mechanisms that people think are involved for sub-seconds versus suprasecond are different. They show different patterns of results. There are some commonalities, but there are some differences. Age does have an effect. It's again complicated, depends, we can talk separately, but let me say that age does. Culture also does, even specific social context. So the only study that I have personally done, that we are familiar with, is Mela, Magh Mela, the Kumbh, as you say, or Mela, as you say, in Allahabad, Prayagraj, now names keep changing. So essentially there we have used a 20-second stimulus, auditory stimulus, and told people that it is made up of, it's sort of noisy signal, noisy audio clip. We just told the Kalpvasis who stay there for a month that it is sort of concocted from the Mela, and for another set of Kalpvasis we told them, are non-Kalpvasis, that it is not from the city, noise from the city. And then people estimate it, they experience it, they estimate it to be of different durations, number one. Number two, that it is dependent on attention, and the way we show it is by asking them to do a concurrent task and then make it a dual task situation so that their attention is sort of divided between this and another task. And then again we show that this particular effect goes away, so which means attention is required for this so-called socio context of cultural effect as well. So, but the specific kind of culture or social context effect depends on the context. There are people who have tried it with different kinds of things. So yes, it does affect.
These are all so important. I'm so glad that you're studying them so carefully.
Thank you.
Yeah, thank you very much, sir. Very wonderful talk. So I want to ask that what is noise in cognitive system and how meditators are reducing the noise? Is it the right statement?
Well, it depends on the model, right? So specific models of phenomena, cognitive phenomena, do use internal noise as well as part of their, for example, the one that I showed, sorry. So for example, this particular model has a bunch of internal noise sources as well. So typically people model it as an additive noise or a multiplicative noise and so on, okay? And there are ways that these noises help or hinder perception in this particular case. So yeah, people do model internal noise. In neural models, people also model neural noise as well. So there are different ways noise is modeled. This is a psychophysical model. So yes, noise is modeled in particular ways. And then whether meditators are better at this, you can sort of infer that way, you can infer it, but it depends. Difficult to sort of pinpoint it at this point in time to say that this particular noise source is what is reduced or changed by meditation. That depends on having a larger model.
Yeah, for example, these irregular thoughts, when someone meditates, it is generally seen that when someone meditates, many thoughts come, right?
Sure.
So we can term it as noise because
you can.
Yeah, but for meditators, they are so practiced and they have so much engaged in that process that they can control that thought.
Yes.
So that is where they are reducing that noise in terms of irregular thoughts and focusing on some.
Because you have now said noise and thoughts are just intruding thoughts are exactly the same, then they mean the same thing. But in a particular model, noise may appear in a particular way in the model, and we don't have a very good model for something like what you just described as of now, because we don't really have a good model of what people call a stream of thought. So we are sort of working on it, but we don't really have a good model at this time to answer it in more precisely.
Thank you, sir.
Continuing to that question, I also have, I'll just take the privilege of, I'm sorry, I'll give you the privilege of chairing the session to ask question. So you showed the study where we have noise plus stimulus, and many of the experiments are showing with instruction. So whatever participants have to do have been instructed. So is there any study where we show two stimulus at the same time? One is which they are instructed to attend, and the other is which they are not instructed to attend, and we focus on the processing of the stimulus which is not being instructed to process?
Well, people generally don't explicitly say that way because it's difficult to verify or implement it. So what people do is that you can sort of force it in a particular way using a task. So similar to what I showed where the dots were flashing, more endogenous versions, for example, of that study have been done. Okay? So even this one, which I just showed, we have just completed, although I don't have the results, I did not put it here, using endogenous cueing, where the cue predicts the location of the scene. We get similar effects. Okay? So just now we completed it. We don't, the results I didn't put.
Do you also have the processing of the scene? Do you have any question which answers the experience of scene, not
yes,
the...
these are the experience of the scene. Is it indoor or outdoor? And this is about the scene only.
Oh yes. Yeah, right.
This 4-point awareness rating scale is for the scene only, not for the writers.
Yes. Thank you.
Good morning, sir. It's wonderful. You very simply explained the whole technical aspect. I have no question at all. But however, I have a request. In your method, you have mentioned that two aspects you are discussing about, that psychophysics and another is phenomenological. If time permits, it briefly can explain about the phenomenological aspects of understanding of attention. Thank you.
So, okay, so the way that we do it, the first step is essentially move away from objective measures of accuracy and reaction time and look for reports of appearance or experience, or reports of experience, right? That's the first step. Phenomenology, of course, it's a loaded word, right? So you have proper phenomenologists, Brentano, Husserl, Merleau-Ponty, and so on. So I didn't talk about this. So one of the things that, because I study time as well and temporal properties, we have tried to use notions from Husserl, for example, on pretension, retention, and so on, for looking at the subjective time. And Husserl has this nice, interesting book on time consciousness. So where he talks about these things. So we have incorporated them in our framework or model, which I did not talk about, but so we have done those as well. Yeah.
My question is, where does, actually it's very curiosity, and the whole over the world is looking for that. Where is that threshold pointing towards the consciousness? So
no, we are simply saying that there are variables or factors, let's say attention, changes those thresholds or slopes.
okay.
Or basically, you can interpret it as attention influences whatever the mechanisms that underlie your conscious experience are, they are changed in a systematic way
Okay.
using attention. That's all I.
Thank you, sir.
Thank you. Can we have more questions afterwards during maybe networking sessions? Due to the time crunch, we will stop here. Thank you very much, sir, for your insightful experiments, and it really gives us a kickstart for how we can actually manipulate our thought and experiences, and we can also prove it with science. So, thank you very much, sir.